Hi, and welcome to this lecture on the composition of the integument, specifically the dermis. As you look at the dermis, it is deep to the epidermis, which I've discussed in the previous lecture. It ranges in thickness from about 0.5 millimeters to 3 millimeters and is composed of primarily connective tissue. Here are some components of the dermis. First, it is primarily made of collagen, with some elastic and reticular fibers as well. They are there to provide strength and elasticity to the tissue. We also have motile dendritic cells that serve as an immune function in protection from foreign pathogens. We also have blood vessels, sweat glands, and sebaceous glands. Keep in mind, sweat glands create the sweat on the outside of the skin or the apocrine sweat glands, which are the ones that are associated with the axillary hair and inguinal hair. The sebaceous glands secrete oil for hair itself. We also have the hair follicles, nail roots, sensory nerve endings, and the erector pili muscle, which doesn't serve any real purpose in humans. The dermis is also divided between the papillary layer and the deeper reticular layer. Here is a figure showing the layers of the dermis. We've already discussed the epidermis, which is here. And as you look at the dermis, you can see that it is broken into the papillary layer and the reticular layer, with the papillary layer being the thinner of the two. As you look at the papillary layer, you will see that it is comprised of dermal papillae. And in these dermal papillae, you see the blood vessels and receptors for things such as touch. In addition, as you look in the reticular layer, you can see the hair, the erector pili muscle, sweat glands, and sebaceous glands. Now, underneath the dermis, you have the subcutaneous fat layer called the hypodermis. In the papillary layer of the dermis, it is the superficial region. It is the region that is closest to the surface of the skin. It is directly adjacent to the epidermis, composed of areolar connective tissue, which is a loose connective tissue. It has dermal papillae, as I described in the figure, that contain the capillaries and sensory nerve endings. You also have the epidermal ridges, which are the projections of the epidermis that are arising from the papillae themselves. Now, the papillary layer and the epidermal ridges help to interlock and increase the area of contact between layers. Secondly, we have the reticular layer. It is a deeper major portion of the dermis. It is the thickest of the two. It extends from the papillary layer to the subcutaneous fat layer, which is the hypodermis. It consists primarily of dense, irregular connective tissue. And the fact that it is an irregular connective tissue allows it to have strength in all directions. It contains large bundles of collagen fibers. These collagen fibers are interwoven into a meshwork that gives it a lot of strength. The dermis does have extensive nerve fibers. There is sensory and or motor nerve fibers. Sensory nerve fibers conduct the signals to the central nervous system. They can do things like detect pressure, vibration, and cold. And the motor nerve fibers conduct signals away from the central nervous system to an effector. In this case, they can help control blood flow and gland secretions. We also have dermal blood vessels. These dermal blood vessels will supply nutrients to the epidermis and dermis. It's especially important to the epidermis because all epidermal tissue is avascular, so this is the only way that they can get the nutrients that they need. The larger vessels are along the reticular and subcutaneous border, and then you have smaller vessels projecting in from that into the dermis and dermal papillae. These play a very important role in body temperature and blood pressure regulation. They can either be vasodilated or vasoconstricted. In vasoconstriction, that is where the blood vessel will narrow its diameter. It ensures that blood is shunted from the periphery towards the deeper structures. This is occurring when you are trying to conserve heat, which is why you look pale in the cold. Then there's vasodilation. In vasodilation, that's where the blood vessel diameter increases. It shunts the blood close to the body surface. It occurs when we are needing to lose heat, which is why we appear flushed during exercise.